Thank you. Okay. Don't worry. I'm going to come right back to this page as soon as the warm-ups are done. Okay. All right. So, guys, silence, please. That means you stop talking. All right. X intersect. Please stop. Y equals 0. Y intersect X equals 0. Okay, so we're going to do two problems. The first problem, we're going to put 0 in the y spot. So x plus 2 times 0 equals -8. X equals -8. Why would they give me one that goes off the graph so far? It's fine. -8, 0. Okay, so I'm just going to make little marks over here. -8, 0 is over there. Okay, now I'm going to put 0 in the x spot. 0 plus 2y equals -8. Divide by 2. Y equals -4. 0, -4. 0, -4 is right there. Get my ruler. So. Okay, any questions about number 8? Okay, now number 10. X1, Y1, X2, Y2, M equals Y2 minus Y1 over X2 minus X1. With this one, you have to be super careful with the negatives. Super careful. Okay, so the top 0 minus -2, that becomes plus, which is just 2. And -2 minus -3, that also becomes plus, so that's 1. Equals 2. Okay. Which point do you guys want to use for X and Y? -3 and -2? Doesn't matter. -2 equals 2 times -3 plus B. -2 equals -6 plus B. a 6, 4 equals B. Okay. Final answer, y equals 2x plus 4. Okay, any questions about the warm-ups at all? You sure? Okay, so you guys are actually done with your packet. You can put that away. Okay, so today we're going to do start area models. This is one of we started it Friday with our e-tool stuff. We're kind of messing around. Today we're going to start it for reals. This is maybe the second most important lesson of the whole semester, except for the one where we did the equation of the line through 2 points, which we just did in the warm-up. That could quite possibly be the most important lesson. This, though, never goes away. These like box things, they last all the way through calculus. Super important that you guys know how to do these to be successful in any further math class. Just to prove it to you, these boxes like this exist forever, all like everything. I will show you real quick so you can see, but like this is what we're working on in our class. This little bit, this is Math 3's notebook. They have to do this whole problem, but this little bit is the part that you're going to learn today. This little bit is the part you're going to learn today. This is, I can't even tell you how important. The good news is it's not hard. It's just extremely important to make sure you understand. And homework tonight is 90 through 95, and see if you can understand my joke. Do you see the distributive property part? That's my favorite part of the whole thing. Do you get it? Do you get the joke? No, unfortunately. No, it's not here. No. Are you even looking at it? Yep. But this is a Lady Gaga song. Yes, it is. Yeah, it's still good. Okay. So, when something's squared, how many times does it happen? Okay. So, what would this be? Yeah. Say it again. It's a song. Yeah. He got it now. I saw the light bulb go on. He doesn't like it, but he got it. He's not happy about it, but he got it. Okay. It's good. It's good. It's a good song. It's old, but good. Okay. Anyway. All right. So hopefully you have this drawn or most of it drawn. We are going to work on the area and perimeter. This is the same thing we did Friday. So the area is just the different types of tiles added together. So we have one XY tile. How many Y tiles do we have? So 2 Y tiles and 2 X tiles. That's it for area. Area is easy. You just add together the number of different tiles that you have. Perimeter is more challenging. So we're going to go around the outside like Eminem. I'm just on fire today. Does anybody know that song? No, you're too young. Miss Destiny knows it. Okay. That doesn't matter. Doesn't matter. It's not appropriate. Okay, anyway, moving on. So this side length is Y. This is 1. What's this side length here? X. I heard someone say it. This side length is 1. This one's also Y. This is 1, 1, 1, X, 1, 1, 1. Am I missing anything? Okay, so how many X's do I have on my perimeter? 2 X's. And I have 2 Y's on my perimeter. And how many ones? 1, 2, 3, 4, 5, 6, 7, 8. Is it 8? Yeah, okay. All right, now that is where you were before. This is a middle school problem. Now we're going to move into the high school problems, but slowly but surely. Like when you're going into a pool with the beach entry and you walk in super slow. Okay, this is one of the diagrams that we made in the e-tool, kind of. And area as a product is going to equal the area as a sum. So we need to review what this means from Friday. We start with area as a sum, and all we do is add together the types of tiles that we have. So this one's an XY tile. What's this right here? I'm gonna actually do this in a different color. What's this tile right here? What type? Y. And this guy up here? Y, okay. And what's this tile? X squared. X, X, X. Does this make sense? Okay, what's this guy over here? X. And then all these little guys are ones. Okay, so when we write the area as a sum, all we need to do is just add up the type of tiles we have. So we have one XY tile, one X squared tile, 3 Y tiles, 5 X tiles, and 6 ones tiles. Have any questions about how I got that? That should be the easy part. Okay, now area is a product is the length times the width. So what we're going to do is look at how long each of the length and the width are. So this length is Y. This length is X. And what's this length right here? 2. So that means the top of this is Y plus X plus 2 long. Okay, now we're going to do the height, which is the width. How long is this piece right here? Okay, yes, but right here, what's this little bit? X, okay. And then this bit up here is 3, because it's 1, 1, 1. So we write X plus 3. So that's the length, and that's the width, and that's all of the tiles added together. These two things are equal because you can find the area by adding the parts, or you can find the area by doing length times width. Okay, go ahead and write down the space for 85 with the blanks. Okay, this is what I'm going to do for 85. I'm going to put up a picture of the tile diagram, just like it is up here. So I'm just going to put up the picture from the ebook for 85. I want you guys in your groups to try to figure out the area as a product and area as a sum from the picture. Are you ready? Yep. Okay, see if you can do it, and I'll put the answer up in a minute. Okay, there it is. Talk about it. First step is to count. Okay, I'm going to show you the answer, and then I will help you with anything that does not make sense. Here's the answer. Okay, so write the answer down if you didn't get it. Then I'm going to go back to the picture and show you exactly where I got these things from. Not too hard. What? Your width is or just hold on. Okay, so write down the answer. Okay, then I'm going to go over it. Okay. The first thing you do, usually what I do is start with the sum. Okay, so I want to start with the sum. That's the easier thing. And all I have to do is count how many tiles there are. So there's 1, 2, 3, 4, 5, 6, 7, 8 x squared tiles. So the first thing I write down is 8x squared. I'm in the sum part. Even though it's second, I start with the sum. Okay, so there's 8x squared tiles. Now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 x tiles. So I have 8x squared plus 22x plus, and then 3 times 5 is 15 ones tiles. So your sum is 8x squared plus 22 x's plus 15 ones. Okay, any questions there? You guys okay with the sum? Yep. Okay, that's the easy part. Okay, now, product, length times width. So the length, this is x plus x plus x plus x plus 1 plus 1 plus 1 plus 1 plus 1. X plus x plus x plus x is 4x. And then 1 plus 1 plus 1 plus 1 plus 1 is 5. So this is 1, 2, 3, 4x plus 5. Okay, now the width is this, x plus x plus 3, 2x plus 3. Okay, now we're going to start getting lazy. Notice when I showed you the Math 3 notebook, did I have all the tiles drawn out? No, no. At a certain point, we just can't do it anymore. Okay, so what we start to do is we start to only draw the parts that are the boundaries between the different types of tiles. So draw this for me. And then after this, we're going to get even lazier. Okay, now how many x squared tiles were there? 8. Okay, and what I'm going to do is I'm going to say, okay, this big section had the 8x squared tiles. I am now grown too lazy to draw them all out. I just counted them. There's 8 of them, and I put it here. Okay, now this section above the x squared tiles up here, how many x tiles are above the x squareds?
12x.
12, yes. So there's 12x above. And how many x tiles were over here? Do you remember? 10. And then how many ones tiles were in this corner? 15. Okay, so this is where we're going. We're going to start getting too lazy to draw all the tiles. And we're going to get more efficient. Okay, so now if you remember, this was 3. And this was 2x. And this was 4x. And this was 5. Okay, really important over here. Do you guys know that x times x is x squared? And x plus x is 2x. You're going to have to keep that in mind in the next problem. X times x is x squared. Yes, sir.
Would it essentially make it a bit harder because you don't know what is like, because you don't, like this 12x, you don't really know if it's like
12 or
3
10.
by
Or,
4 or something like that.
Totally. But luckily on these, instead of giving you a big picture of tiles, we give you some pieces and you fill in the rest. Okay, so this is an excellent segue into number 87. Okay, so now we're starting to get to where this is going. Difficulties. Okay, so for Landon's point, he's saying, well, how do you know how many x tiles are there? That's the piece that's going to be given to you in problems like this. Now you see I've gotten even lazier. I've just not written area as a and area as a because we know we're talking about area as a product and area as a sum. So we've done it several times now. Okay. This is where this is going, and it's super important. Okay, so do you guys see this little box right here? This very top left box. What is the height of this box? X. And what is the base of this box? 2x. Okay. What is x times 2x? 2x squared. Remember, it's times because it's base times height. That's why we're working this out. Okay. All right. Now, this little box down here, its height is 5 and its base is 2x. What's 5 times 2x? Yes. Nope. Times 10x. Remember, it's times. It's why we're doing it. It's okay. We're working out all the stuff right now. Okay, so now I go to the top right box. The height of that is x. The base is 3. What's 3 times x? 3x. And then the bottom right box, the height is 5. The base is 3. 5 times 3 is 15. Okay, now when we do these in this class, most of the time, these two boxes will be like terms. And I'll circle them like that so we can combine them. Okay, now the product is really just the question. So 2x plus 3 times x plus 5. So product is length times width. Length times width. You can put x plus 3 plus 5 in front and 2x plus 3 second also. It doesn't matter because multiplication can go any which way. Okay, now the sum is the number of tiles inside the boxes. So we have 2x squared tiles plus 13x tiles plus 15 ones tiles. Okay, now we're going to do B, which is an easy one. And then I have a challenge one for C that I want to see if you can do on your own. Okay, for B, this box, the height is 3, the base is Y. What's 3 times Y? 3Y. Second box, height is 3, base is 5. 3 times 5, 15. Do we have any like terms here? No. Okay, product. Y plus 5 times 3. Base times height. You don't even need to put the little dot. You could just put the 3 right next to it because that's what times means. But I like to put that just so that we know. Okay, and then the sum is 3y plus 15. Okay, now I have a spicy one for you to do in your by yourself or with your group, either way. See, it's spicy. Give it a try, and then I'll go over it in a few minutes. All right, let me fill in a couple of the boxes that you might be wondering about. This box here is negative 42y. Does that make sense so far? Okay, this might be the other box you're wondering about. This is 24y squared. Because it's y times y. Okay, this box is negative 7x. This box is 4xy. You don't have to put x and y in that order. You could say 4yx if you want to. I just put things in alphabetical order because I'm a nerd. This box is negative 7. And this box is positive 4y. Okay, next thing I'm going to do is look for any like terms. Do you see like terms? This one and this one. Okay, so product. 6y plus x plus 1. So there's the base times the height, 4y minus 7 equals, the order of these does not matter. 24y squared minus 38y plus 4xy minus 7x minus 7. I went way over my line there. Yes, okay. The order does not matter. So as long as you have these things in some order, it's fine, but you can have them in any order you want. I don't care about the order. Now, when we get down to number 88, I am going to care about the order. Okay, we have one more problem. And we need to add one more thing to it, and that is, how do I figure out the size of the box I need? Okay. On example 1, how many things are in the first parentheses? 2 things. And how many things are in the second parentheses? 2 things. That means I'm going to need a 2 by 2 size box. So 2 by 2 size box. Okay, this is the part where it's going to be personal preference. You can put the x plus 4 on the top or the side, it doesn't matter. I usually put the first thing on the top, but you don't have to. This is the end after this one. And then you can put this one on either side. It doesn't matter. Okay, so what is x times x? X squared, beautiful, perfect. What is x times 4? 4x. What is x times 2? Yep. A couple of us have this down. 8. Okay, so you decide on the size box, multiply it out, and then check for like terms. And then up here, you already have the area as a product as your answer, or as your problem. So just write the answer, which is x squared plus 6x plus 8. Product sum. Okay, last problem of the day. What size box do I need for this? 2 by 3. Beautiful. Nope. Okay, here's the big question. What is 2x times x squared? Yes, 2x cubed. Negative 3x squared. What's 2x times x? 2x squared. Negative 3x. Negative 2x. Be very careful. This is positive 3. Find your like terms. Okay. 2x cubed minus 1x squared, and I just put minus x squared. You could put minus 1x squared if you want to. Minus 5x plus 3. Okay, real quick. Wait. Pause. Just give me 1 second. Okay. These answers, you know how I said I didn't care about the order of the things? These ones I care about the order. Okay. This one, notice it went cubed, squared to the 1 power, no x's. That one went squared to the 1 power, no x's. This is called descending order, which means the exponents are going down each time. So I care about the answer.